Thank you very much. Hi, I'm Steven. This is my talk, Coding Complexity with Component-Based Coding. Before we get started, I have a very quick disclaimer. None of these ideas are mine. I didn't think them up. I'm just implementing them, telling you why they're awesome, and thinking on how to implement them correctly. Furthermore, nothing I say in this presentation is guaranteed to work for you. Um, Everything, this is about how we looked at our problem and solved it, and hopefully you can get some good ideas from it. Um, if you see something you're like, oh, I did that, don't worry. I'm not blaming you. I'm not saying you suck. I'm not saying your code sucks. We're all victims of our own of the circumstances. It used to suck. So I'm Steven and Hartog, and I've been working at bol.com for a little over 3.5 years. And since 2.5 years, I'm one of the backend developers of our massive webshop. And since 1.5 years, I have a role as one of the 4 software architects, and we make sure that we build a clean architecture for everybody to work in, and we do a lot of work to uphold our coding standards. My hobbies are reviewing merge requests, commenting on them, and a lot of refactoring of code. And I really, really do like helping people come up with better solutions for their problems than they might have naively thought of. So a quick introduction to our webshop. What we refer to as the webshop is our main customer-facing website. So this is www.bol.com. And generally, it consists of 3 domains. There's the catalog, or as we refer to, which is the part where you shop around, you click, you find some products, you search a little bit, the homepage. And this is where we try to entice our customers to buy a product. Then we have the checkout, which is the part where people actually pay for their products and get it delivered to them. And then lastly, we have account slash customer service slash aftercare, which is the whole shebang that comes afterwards. Most of this talk it will be about the catalog because this is where I work, and this is also where we have a lot of issues that I will be explaining later on. The technical part of our webshop is much more interesting. So we have a really big Java application that builds HTML pages. We have a ton of requests per second. We have really heavy load during the season. And one of the things that many people do not realize is that it's not only a Java application that builds HTML pages, we're also one of the largest data aggregators in the entire company. We have about 80 services that we call and we aggregate data from. For this, we need a ton of code and a ton of developers. So we have massive amount of code files, and we have more than. I did some kind of diagnostics on our Git repository, and in 2020 up till now, this is even probably already outdated because we have some new developers. We've had more than 70 unique committers with 5 commits or more. And we are also a really big legacy application. We still have code from 2008. So sometimes you're working in a file, and you put on git annotate, and you see the fat dark red, and it's saying, this code is from 2008, and at that point, you're screwed generally. Additionally, the code is actually much older. When I was making this presentation, my colleague reminded me the code is not from 2008. That's just when our Git repository was created. So our main problem was, well, our code sucked. So what was the actual problem? In the web shop, we have a lot of front end that appears in a lot of places. We have a lot of ways to show products. We have a lot of places where we try to show products to customers and get them to buy them. And the issue that we ran into is that this was all copy pasted. So, for example, here we have a buy button. I took some screenshots from all over our web shop. Everywhere we have this yellow buy button. Everywhere it looks the same. Everywhere it's supposed to act the same. But in reality, everybody was just copy pasting code everywhere. So this gives a lot of scalability issues. One of the big problems is that if you need to change your generic buy button, you have to change it literally everywhere. This costs a lot of time, and it makes big gradual changes across the entire web shop almost impossible. Another problem is that instances of code start diverging because every place where you put it, will just be just a little bit different. You need some extra CSS class, or you need some extra JavaScript logic. So what happens is that you have code copy pasted everywhere, and every single instance is different. And then you run into the new problem. You have to make a new buy button. Well, where do you copy paste it from? Every single one is different. How can you ever know which one is correct? So our solution to this was to build our own front-end component system. It's called Runway, and with Runway we have a front-end component library to make sure that each front-end instance is there's only one instance of each front-end thing that we have. So for example, I've made a picture here where I have a buy block from our product page, and each and every single component I have aligned with a green line. So for example, the entire block is one component. Then each segment of the block is one component, and then it gets even smaller. So for example, as you might see, there's even a green line around only the price, $32.99. But it's something that we duplicate a lot, and it actually has quite a lot of logic in there on how to show it. So we make sure that it's one component that we can reuse everywhere. Now, the way Runway works is that we have one component, and for each component, a data contract is created. And with this data contract, we can create a front-end component from the Java code. So Runway generates Java code based on this contract, and then we can call it from our application. Of course, it didn't solve the problem. The problem just moved towards the back end. So now we only had one instance of each front-end component. And the pattern that we had in the Java code is that we would have component creator classes, and each component creator, or CC as we refer to them, would create a front-end component. They would fill in the contract, and that's all they did. The generic architecture of how our pages looked is that we are starting to build a page. So we have a page at the very top, and this page has a model, and this model would have something like, if it is a product detail page, it would have the product information. But if it's a search page or search result page, it would have the result from our search service. Or if it's a recommendations page, it would have the recommendations for the customer. So every page would have a model. And then every model, and then the page has to make components for every region of the page. So the page model is put into the component creator, or the CC of the page region, and then this creates a new model. And then with this model, it creates all the components that are below it. And those components take the model from the parent, then they create a new model. And with this new model, they create the CCs below them. So the issue was that every component creator had a model that was used as input parameter, but this model was in its core always based on the page it was on, and even the page region it was on. So the main problem we ran into is that the component creators could not be reused at all. So we would have one front-end instance, and in the backend we would have like 5-6 different component creators for one front-end instance. And this, gave a lot of problems, because then suddenly, even though they look visually the same, the data starts differing for every front-end component. Additionally, we had two other problems. Not only could we not reuse anything, they could also not be tested in isolation. And this gave us really big problems with testability. The main way we could test things was with huge fitness tests that did the entire page just to check one small piece of it. And the reason why we could not really test in isolation is because a lot of the logic was built into the model that entered the component creator. And this is also the third big issue that we had, is nobody could ever find where the logic was. So the situation that we would have is that we had a component creator, and the input for this component creator was a model, and the input for this model was another model, and the input for that model was another model, etc., etc. And every single conversion step, you just have a little bit of logic. Tiny bit of logic here, tiny bit of logic there, tiny bit of logic there. But this made it really hard to follow the entire chain of events. So what would often happen is that someone said, I have a website open here. I see this number over here, and in my service, this number is different, and they should be the same. Why are they not the same? Or maybe they should not be the same. And then you have to go through the entire chain and find out where the hell is this transformation taking place. So our solution was to have no models, because in its core, we thought our problem lies with the fact that we have models everywhere. Our new core architecture focus is based on the component creators. And the main design philosophy that we have is each component creator should be able to render fully in isolation. So that means that they don't need any dependencies on other existing models or classes or whatever. And the way we do that is by making sure that we don't use models, we instead use identifiers. Because we never want to render a model in something. We always want to render an existing asset or an existing thing or an object that is in our ball.com landscape. So we never want to show, this specific product model that we have. We always want to show a product ID, or at least we want to show the product belonging to the product ID. We don't want to show a price. We want to show a specific offer. We don't want to show some kind of seller model. We want to show the seller. So we realized that we could, instead of passing down models, we could just simply pass down the identifiers. So the new situation that we have, or at least the old situation that we used to have, is that we had a product tile CC, for example, a component creator that created a product tile, and this had a product model as an input. And instead of that, what we now have is that we have a product tile CC, which takes a product ID as its input, and then from this product ID, it goes to the service itself, and then depending on the response from the service, it also does the logic itself to extract values from that model. So generally, how it would look like on a full page is that we have a controller at the very top, and this controller has. I've made a product page here. And this controller has a product ID because that's in the URL, and then this product ID is then propagated to every component that is a subcomponent of the component being called. So the product page CC passes it down to the product page content CC, etc. And then what we have here is that we have a price CC that is called by the identifier from the controller. However, on the product page, we also have recommendations that we would like to show. So we have a recommendation CC, for example, and this recommendations component creator will call one of our recommendation services, and the recommendation service, well, they don't return a model of a product, they just return product IDs. So then we can just call new CCs and pass down the product IDs that we've gotten from the services to them. And then here, for example, we see that a price CC is called 4 times in this graph alone with different identifiers. So here's a little bit of our of pseudocode. This is the only code that you will see in this presentation. So many of our component creators will look like this. So we have a builder. We need to set some properties in this builder. All we have is a product ID. So we just go to the product service ourselves to find the product. And then we use the service model directly. So we just ask, what is the title of this product? If we need to have some more complicated logic, so for example, here we have an example where we need to get the most important brand from a product. From our component creator, we just call a logic class that extracts the most important brand from our product. And then we also have often that we need to call other component creators, so we just pass down the product ID towards them. As I have said, we use the service models. This is something of a taboo, but we have decided to drop all of our own models and instead use the models that are actually returned by the services that we call. Of course, we still use our own data classes ourselves, but we base it heavily on their model. And the only transformations that we allow are for convenience. So sometimes you have weird JSON structures and you have to convert those into Java. We rename stuff because they're more clear for us, and we leave out fields we don't need to use. But one of the very important things that we want to accomplish is that in our transformations, we should have absolutely no business rules. because these business rules are almost impossible to find out later. Um, and a lot of people are going to hear this and they're going like, "Oh, dude, you're doing it completely wrong. You have really tight coupling to your services, and you need loose coupling." And I'm telling you, that's right. We have tight coupling, but what we have seen in actual real life circumstances is that this tight coupling is going to be there no matter what, because if you need to change the data, or at least the servers that your data is coming from, they're going to have a radically different model anyway. And if their model is the same, well, then it's going to be a really easy migration. However, I've mostly been raving on about identifiers, but they don't cover everything. Um, Identifiers are passed from the parent component, but you just need a little bit more information. So, for example, one of the things that we run into often is that we need information about the request itself, or about the customer state. So, for example, we need to know whether the customer is logged in or not. Or we need to know what their current country is, or the language they would like to see the website in. We also have A/B test bucketing, where we need to know, like, should we show this cool new feature to the customer or not, so that we can test it. So we have a context which is floating around, and then from every component creator, we can just ask the context about current request information. So we can ask the context, is the user logged in or not? And the third thing that we use for our component creators is that we pass down additional configuration, because we realized every component is the same and we want it to be the same everywhere, but that's not the case. That's not how real life works, because in every place where we put a component, it's going to be just a little bit different depending on the context. So if we have a really generic product tile, well, in one place we would like to show the price because it's very important for the customer. But if we want to show it in a context where the user has already bought the product, it sounds really silly to then show the price to them. So we need to always pass down a little bit of configuration from the parent, and we try to make these as functional as possible. So like Boolean flags, like should we show the price or not? One of the things that you might notice is that, well, if in every component creator we call the service to get the product, the information from our identifiers, then you're going to run into massive performance issues because you have to do the call every time. We have a lot of Spring request functionality in our web shop, and we have a pattern where we use request scope caching before any service calls. So every time we do a request to an adapter, there's a cache in front of that, and before we go to the adapter, we check, well, has the user already done this request? And if so, we just return that. Additionally, for all of our context, etc., we use request scope beans, and these are instances of beans that are only there for the duration of the request, and this makes it really easy for us to model the cloud context that we really desire to have. With such strict things, like for example, you always have to go through request scope caching before you go to an adapter, we really try to make sure that it's as hard as possible to break our architecture. So one of the things we did is that Runway generates a contract for each component, but in addition to that, it also generates abstract classes. And the way we have built it is that if you want to create a component creator, all you have to do is extend an abstract class that exists. You have to fill in the identifiers that you're going to use, and then you have a class where you just, tell IntelliJ to fill in the methods that you need to make. Then you just fill in the builder, and you're done. And this makes it really easy to start using the architecture. It makes it harder to break the architecture, and it makes it so that the web shop is generally very, very consistent. Additionally, we currently make really heavy use of ArchUnit, which is a testing framework to unit test your architecture. We have a lot of ArchUnit tests to make sure that nobody breaks the architecture. And this is mostly for their own benefit, because usually when you break the architecture, what you're doing is not going to be a good idea. What I didn't talk about yet is how we do our testing now, because we have isolated testing. So as I show here, we have some kind of contract where you have to extend an abstract class and you have to throw in a couple of identifiers. And this makes it really easy to create your own testing application. So we have built one, and we have an interface that we can use for local development and that we also use for our component tests, where we have just really easy input of our component creators, because all they have is identifiers, which are just strings below the hood, and they have configuration. And the configuration will usually just be either booleans or nested configuration. So we have this really cool testing application where we can just fill in the numbers, select some booleans, and then we immediately see what the output of this will be for the customer. The only problem that we have is that the context is not really that easily modelable. So for the context, we do some stuff with cookies, and then you can have cookies that say, I'm a Belgian customer, or I wish to be in this A/B test. It's not ideal, but it works pretty good. And the awesome thing about this is that we can do everything isolated, because every component creator goes to each service by themselves. This means that if we just call the component creator, everything is always calculated, and we just stub out the services, and then we have fully stubbed out tests. And the cool part is even that everything is a component creator. So that means that at any level, we can build stuff in isolation. So for example, I can have a product tile, I can build it in isolation, but I can even build an entire page in isolation. So our component tests can even support testing the entire page. So we had three big issues. The first thing is that our component creators could not be reused. So we solved that by having identifiers as input, which made it really easy to reuse component creators. The second is that component creators cannot be tested in isolation, and we have this really cool testing application, and we can do everything in isolation. And the last thing is that nobody could ever find out where the logic was. And we fixed that by making sure that all logic is always downstream from the component creator, so the component creator is always in the lead. I think we have succeeded, and I really enjoy coding in our current architecture. So this is the end of my presentation. Does anyone have any questions?
Thank you so much, Steven, for this really deep and very clear presentation. There were some questions in the Q&A. There was also someone called Not Steven in the Q&A who was answering most of the questions, but I'll hand some of them to you as well, because we still have 7 minutes before the break. So the first question by user Gotta Love the Disclaimer. How do you ensure every one of the 73 committers adhere to your design and coding patterns?
Yes. That's a pretty good question. It is pretty hard. So one of the things that we do is arch unit tests, as I mentioned before. So whenever you do something that's not allowed, you just have a failing unit test and your GitLab pipelines will fail. The other thing that we have is mandatory code reviews. So we have a code review channel, and everything that you want to merge has to be code reviewed. Sadly, we cannot 100% enforce this. We have turned off pushing to master, so you can only do it with merge requests. But because we are not yet on GitLab Premium, we cannot enforce that users cannot click the merge button. But soon we can enforce it, so that will be great.
Okay. Then I have another question from user John Black. How do you ensure that page loads are fast enough given all the components, layers, and service calls?
Yes, I actually have some slides prepared. I had bonus slides. Performance is a big issue. As I mentioned before, we do have the request code caching to make sure that each call is only done once. But the problem is that if you just do naive request code caching, then you will still do every call one after the other, and then it gets pretty slowly after a while. And then you also miss out on the fact that, for example, if you need to show a list of products, which we often do, so for example, on the search result page, you have to show all the search results. if you do every call one after the other, you miss out on bulk calls, for example. And bulk calls are often faster than doing a lot of singles sequentially. So what we often do is that we have preloaders. So a parent component is going to render its children, and it's going like, well, I'm pretty sure that I'm going to need at least the product information about this, or I'm going to need the offers, or I'm going to need the images. So we just run a preloader that fetches all of it in parallel. The result we put into the request scoped cache, and then later on in the component we read from the request scoped cache. And what happens is that the flow on production is actually subtly different from the flow in your isolation tests, but in the isolation tests everything is still working as expected.
That makes a lot of sense. Okay, one final question. So the user Sean Connery asks, how did you migrate from the old spaghetti code to the new model?
Oh man, I'm loving these names. Yeah, migration is pretty hard. The good thing about this is that because we're based on identifiers, in every model you still have the identifiers. So you can start migrating from the bottom up. Actually, we have had two really big migrated pages, and on one page we just built a new page next to it, which took a really long time to go live, sadly. And on the other page, we went from the bottom up, and every component we just replaced with a component based on identifier. And by linking your cache as well, you can make sure that you don't do double calls. And then the frustrating bit about it is that, you know, the deeper you go, the cleaner it is, and then your controller is still this really shitty legacy code. But it is pretty. It's a pretty good way to migrate.
All right. I think that covers most of the questions. There were still, I think, 10 more questions asked. We sadly don't have time for all of them.
I have a really quick one that I can answer. Do the component creators have fallbacks when the servers fail? Generally, we just don't show anything, because when we can't find product information, the user is not going to notice. Generally.
All right. Well, thank you, Stefan, again for the brilliant presentation and the really good answers to all the questions. We right now have a 7-minute break before we go to the next two sessions. You can find the URLs in the Q&A. And if you have any other questions for Stefan, you can go to the Google chat room, and there you can ask questions and start maybe a longer discussion like Bart Enkelaar was trying to do.
Yes.
And for the rest of the day, I wish you a happy Space Summit.
See you.